Hello, people. How are you doing? Welcome back to another edition of Math 20-1. Today we are going to graph some more reciprocal functions. But before we get into this video, make sure you go and you like this video and you subscribe, and make sure you click the little notification button and turn on your notifications. If you don't do that in the next 7.2 seconds, you will have bad luck for the next 55 years of your life, and no dog will ever cuddle you again. I don't know if it's true or not, but I wouldn't risk it. So you better like, subscribe, and hit that notification button so that you can see all the math content I create in the future. Yeah. All right. Do you guys just skip the first 30 seconds of every video? That's what I would probably do if I were you. Today, we're going to do some more graphing like we did yesterday in 5.7. 5.8, we're actually going to break up into two parts. So I'm going to try to do two shorter videos. We'll see if it goes well. Let's get into it. So let's review a little bit about what we learned yesterday. It says which statement about this equation right here is false. Okay, which is false? A says the graph has a vertical asymptote at x equals -1/2. Okay, what is a vertical asymptote? A vertical asymptote is the same thing as an NPV, right? Same thing. So what they're telling you is that x cannot equal -1/2. Well, let's look at this equation and see if that's true. If I put -1/2 into here, what would happen? Well, I would have 1 divided by -4 times -1/2 minus 2. That would be 1 divided by 0. That's not allowed. That is true. So that is a true answer. The question wants to know what's false. So it's not A. Oh, I got a little excited there and I screwed up. Part B, the x-axis is a horizontal asymptote. So this means that you're not allowed to graph on the x-axis. That's actually always true for all of our questions. So that is a true statement. C, the graph has an x-intercept at x equals -1/2. Well, wait a minute. This thing kind of contradicts this thing. This said that you had a vertical asymptote at -1/2, which means you could never equal -1/2. This is now saying that you do have a value. In fact, it's an x-intercept at x equals -1/2. That certainly can't be true, so that is false. So the answer is C. You can't possibly have an x-intercept at a point that is also your asymptote. Not possible. D says the domain is XER, except x cannot equal -1/2. That's true. X could be any value as long as it is not -1/2, which was our NPV. Awesome. That's a little bit of a review about asymptotes. Part B. Which point on y equals fx also lies on 1/f of x? Also lies on. That has a term. It's called an invariant point. These are points that are on graphs and then also on their reciprocal, which is 1 divided by it. They happen at y equals 1 and y equals -1. If we look at this graph, y equals 1 is right there. So C would be 1 point, and y equals -1 is right there. That means A is another invariant point. So A and C would be my points that are on both graphs, both the original function and the reciprocated function. Cool. That's review on invariant points. Today what we're going to do is we're going to do more reciprocals. Today we're going to reciprocate quadratics though. When you reciprocate quadratics, you're going to get any of these three scenarios. I don't want to spend too much time on them. We're just going to get right into it so you can see what happens. But those are the three different scenarios we're going to get. We're going to get graphs that look like this, which just have like one little bumps. We're going to have graphs that look like that, with 2 lines, and then we're going to have graphs like this, which are crazy. They have tons and tons and tons of lines. Let's do it. So sketch the graph of, and then it gives you y equals 1 divided by, and then that thing. To graph something, we first have to know what the original function was. So this blue function you could put in your calculator and graph it. And if you graphed it, you would have a point at about 0.5 right there. And then it would go down like that. Yeah, I can do better than that. We'll go with that. So that's what this function that I've circled in blue, that's what that quadratic would look like. Negative 2x squared minus 0.5. Our goal is to graph the reciprocal, which is 1 divided by it. To do that, we had 3 steps we had to follow. The first step was to draw your asymptotes. Asymptotes happen at 2 different spots. The first spot was your NPVs, or if you're looking at the original graph, it also happens to be the x-intercepts. If you look, this graph actually has no x-intercepts, and it also has no NPVs. Therefore, it has no vertical asymptote, meaning there will be no vertical dotted line like that we can't cross. The second asymptote that we talk about is the x-axis. There's always an asymptote right across the x-axis right there. That's a line we cannot cross. So when we reciprocate our graph, it can't go to the other side of that thing. Awesome. Second step to every reciprocal question is to draw your invariant points. These are points that are going to be on my original blue graph as well as on my reciprocated red graph. Invariant points happen in 2 spots. Y equals 1, which this graph nothing equals 1. And the second spot it happens at is y equals negative 1. This graph does equal negative 1. It equals negative 1 right here and right here. Awesome. Our third step is now to reciprocate. And when we reciprocated yesterday, we just kind of drew it out, right? We put our pencil on and drew it. But with quadratics, you do have to reciprocate some individual points. In particular, you have to reciprocate the vertex. So you need to go find where the vertex is. At this case, it's at negative 0.5. And you need to reciprocate it. That means you need to do 1 divided by negative 0.5, which if you put in your calculator is negative 2. That means this point will reciprocate. It'll move down to negative 2. So it's important that you reciprocate your vertex first. Then you can reciprocate everything else. Cool. To reciprocate these graphs, what you're going to do is this time you're going to actually start at your vertex. So you're going to put your pencil on your vertex. Then you're going to go towards your asymptotes. Now there's 2 ways I could do that, right? I could go to the right and go to an asymptote, or I can go to the left and go to an asymptote. And when I go in those directions, I see invariant points on both sides. So I go towards the invariant point like this, and then I curve along the asymptote and draw a line. And I do the same thing to the left. I curve towards the asymptote, touch the invariant point, and then run along the side. That green graph is my reciprocated graph. And I'm done. So a review of what I did. I drew my asymptotes. which are my NPVs, which I didn't have, and my horizontal one is my x-axis. I then drew my invariant points, which are those yellow dots there at y equals -1. I then reciprocated my vertex. So I found my vertex. The y value was -0.5. I reciprocated -0.5 to become -2. And I drew a dot there. I then knew to start at my vertex now, go towards my invariant point, and then towards my asymptote. And I did it in both directions. If you want to see why that shape happens, you could move other points. So for instance, if we think about it, take a point like that right there. That point has a y value of -3. If you reciprocated -3, it is -1/3. So this point should get smaller and go down to here at y equals -1/3. And you could do that for all these points. Like this one is at -6. That means it should go all the way down to -1/6, a very small number up here. You could go all the way over here. This is y equals -9. The reciprocal should be -1/9, which is a very small decimal. And if you look, it reciprocates all the way to a very tiny y value decimal, which is why these reciprocals look the way they look. Okay. The next question is for you to try. So if you want to go ahead and give it a shot. Oh no, I erased my original function. I'll draw it back out. You can pause this video and you can flip over to the next one and you can give it a shot. And then I'll go over the right answer and you can see if you got it right or wrong. If you get stuck on a step, unpause and watch that step for help, and then pause and try to do it again. The original function for this one looked like this. There we go. Okay, hopefully you paused and tried it. To start this question off, you had to graph this to see what it looked like. This had a y-intercept at -1 right there. And then it would have gone off and down. Like that. The first step to all these questions is to draw your asymptotes. The first asymptote is where your NPVs are, or your x-intercepts from the original graph. There are none. There's no NPVs and there's no x-intercept on that blue graph. Second step is to draw your x-axis as an asymptote. So that would be right here. That's the first step, asymptotes. Second step is to label your invariant points. These are points that will be on both the blue graph and my reciprocated graph. The first spot we get invariant points is at y equals 1. Nothing equals 1. The second thing you'd want to do is draw an invariant point at y equals -1, which happens to be our vertex right there. This is going to be a unique situation for us. The third step is to reciprocate. This is a hard one to reciprocate. The reason it's hard is because we only have one point right now. We only have that invariant point. We have nothing else to reciprocate. Normally we would reciprocate our vertex first, but our vertex is our invariant point. -1, the reciprocal of -1 is -1, so it doesn't move. So the second step of reciprocate everything else, if you're ever lost, just reciprocate a couple random points to see if you can find a shape. So for instance, if I took this point right here, which has a y value of -2, the reciprocal of -2 would be -1/2. So this point should go to here at y equals -1/2 or -0.5. And then I can see my graph is going to look something like that. And it'll do the same thing the other direction, because if you look, that's at -2, so that should also reciprocate to -0.5. So again, it should look kind of like that. And I go towards the asymptote, and then I just run along the side of it. You should have that green looking graph as your answer. When I'm marking these things, I mean, obviously we're not going to have written response because it's online, right? It's just kind of not feasible. So instead, if it was, let's talk about if we still were in a regular world. The way I would mark that is I would look to see if you labeled your invariant points properly. I would look to see if you labeled your asymptotes, and then I would look to see if you reciprocated your vertex properly. If you have those main points, the rest of the shape is just an estimate. But I would definitely want your invariant points labeled and your vertex labeled. Awesome. Let's do 2 more questions. I'll show you one, and then you can try one. We're going to try to graph this thing. To graph this, we have to start with the main thing, which is this. If you graphed it, it ends up having a vertex right there at x equals 1. It's also the x-axis. And then it's going to be quite skinny. I believe you should have a graph that looks somewhat like this. Ugh. I'll try again. Wasn't that bad, but it wasn't good. Hey, that's as good as it's going to get, probably. Oh, gosh, that's really bad, actually. The left side was good. The right side went so poorly for me. Last try here. As good as it's going to get. All right. To reciprocate that bottom graph, I'm following my process. The first step to my process is my asymptotes. My asymptotes happen at my NPVs, which are also the x-intercepts of the original graph. So for instance, if we look at this question, the NPV would be x cannot equal 1. But if you look at my original graph, that's also where there's an x-intercept. So you can either look at it visually to find your vertical asymptote, or you can look for the NPVs if you're given the equation. The second asymptote you have to draw is your x-axis. Second step, draw your invariant points. These are points in which you will be on both graphs. They happen at y equals 1, which there's 2 spots. There's one there and one there. And the second thing is y equals negative, or it does not equal. Y equals -1, which doesn't happen on this graph, right? -1's down here. Awesome. The third step is to reciprocate. Now, when you reciprocate this, your first job is always to do your vertex. But your vertex is your asymptote, so you can't reciprocate it. So what you need to realize is when your vertex is your x-intercept, that means it will be your NPV, it will be your asymptote. You can't actually reciprocate it. So you just have to jump right into everything else. To do this, I like to imagine that this question, the asymptotes basically break up your question into chunks, right? This is 2 chunks. There's one chunk right here, which is on the left side of the asymptote. So this green line I'm drawing, that's 1/2. It's on the left side of my asymptote. And then there's a second half over here in purple. You essentially have to graph both halves separately. Imagine it's like just that half. It's a little linear equation you want to do. So like if you wanted to grab just this light green side, I would put my pencil on my asymptote. Oh no, I lost my picture. You guys are probably like, no, he's drawing it again. Oh yeah, and then I get my best one. Maybe it was meant to be. I would put my pencil on my invariant point. I would go towards one of my asymptotes and then run along it, like a dog runs along a fence. And the same thing happens the other direction. You go down towards the asymptote, you curve, and you go beside the asymptote but never touch it. That would be the left side of my quadratic. On the right side of the asymptote, the same thing happens. I go up and along my fence line. I go down and along my fence line down over here. Like that. That green function would be my reciprocated function. It would be this thing. Y equals 1 over 3 times x minus 1 squared. Cool. I got one left for you. So pause the video. Try graphing this. The original function would be right here. And then it would go down like this. Okay, give it a shot. Okay, the first job that you had was to draw your asymptotes. Asymptotes happen at your NPVs, which is also your x-intercepts of the graph, the original graph. In this case, my NPVs are at x equals -2. The second one, which people often forget, is the x-axis, and that's always there, right? So make sure you always have that one drawn out. Perfect. Second step after asymptote is your invariant point. Your invariant points happen at y equals 1 and y equals -1. In this case, -1 happens twice, right there and right there. The third job is to reciprocate. Normally, on a quadratic, we reciprocate the vertex first. In this case, if you reciprocate the vertex, it's your asymptote, so you can't. So then you just go ahead and you do everything else. If I look at this as two halves, the left half of the on the left side of the vertical asymptote, I would have this graph. Start at your invariant point, go towards your asymptote, draw a line. Go down towards your other asymptote and draw a line. That would be the left side of my reciprocal function. On the right side, I would have to do the same thing. So this yellow goes down like that. And it goes up and to the right like that. Awesome. Hopefully you got it right. You guys can go ahead, do some practice. We will do more quadratics tomorrow. So we'll do what happens when you have two x-intercepts in a quadratic. And then we will be done for the Christmas break. Hoorah. Have a great rest of your day. Later.